But if you're unsure of what a scrub seal is, I think you'll be okay. If you understand a chip seal, you'll pick up on it pretty quickly. Basically, a scrub seal is just an application of asphalt emulsion that is used just like a chip seal to go down on the ground and lock down your aggregate. It can be used as part of a final surface, as part of your program, or it can be used as an interlayer. I would say Mississippi has done several interlayers the last 3 years, even on 4 lanes, probably over 100 lane miles at this point. I know one project had 80 lane miles in it by itself, but it can be as an interlayer, it can be a final surface, but it's used to soften your asphalt. It's used to correct oxidation, lock down, raveling, improve your friction. Like I mentioned, it's really close to a chip seal, but the main difference is that it has a different emulsion. Some states call it a CMS 1PC. It's just a cationic medium set emulsion. It's not like the rapid set emulsions that you normally see with chip seals. You want to give that emulsion a little bit of time to cure, to be able to work through the broom. You generally have a lower viscosity so that it can penetrate down into a crack. And then you have the addition of a broom sled. And that broom sled is used to help get the emulsion down into the cracks, because that's what we're trying to do. Arkansas actually calls their specification a rejuvenating mass crack treatment. And I like that name because it's actually defining what the treatment is used for. You want to use a scrub seal when you've got so many cracks that are out on the road that it would not be economical to try to go out there and fill them with a wand or hand seal them or pour them or whatever you're going to do with that. So that's what I like about a chip seal. This is kind of, you can tell from the picture, the treatment from the earlier picture, that the treatment had been around for a long time. Now I don't know where that was, but I always think that's a fun picture. But this is kind of a common broom sled today. This is a broom. This is a picture taken directly off the back of an asphalt distributor. And what you can see there, and what's really important in this picture, is that wave that's in front of that broom. Okay, that wave is, if you're out on a scrub seal job and you see a broom being pulled that doesn't have a wave, then it's not getting the full benefit of what we're trying to do with this treatment, because we need that wave to have that volume, the extra volume of emulsion to get pushed down into the crack. Okay, that is very important. Here's a quick video of maybe help us understand. I hope this works right. Now what you'll see here is the asphalt distributor spraying the asphalt on the emulsion on the ground. Now, if the very next thing came through was the chip spreader, what we would have is a chip seal. Okay. Now, if you notice, look at that crack. Notice that it got emulsion in it, but it really didn't get a lot of emulsion in it. It didn't fill that crack up. Now we can see the broom come through with that extra volume, that wave, and see how that filled that crack up. That's what we're trying to accomplish. Now let me set some expectations on a scrub seal. I don't want to oversell it. This is a perfect video. This is a top-down crack where everything penetrated perfectly. The depth of crack, width of crack, everything like that will determine how full that crack gets with emulsion in it. You can't always expect cracks to be filled this completely. Sometimes we go out on jobs and we can actually stick a ruler down, and get a crack maybe 12 inches deep or something like that. So it will obviously be depth of crack to see how well it is. But you see the concept of a chip seal just does not necessarily fill up the crack. Chip seals should be limited at maybe about 1/4 of an inch wide on the width of crack, whereas a scrub seal can be used for cracks larger than that. Here's another video. This is in slow motion to give me just a little time to talk. But as with the chip seal, do you see those lines, those white lines that are in there where the emulsion is not getting full coverage across the road? If that were a chip seal, no rock would stick there in that section. And it would go the entire length of where that was happening. It would be an eyesore. You wouldn't have full coverage. Well, you can see as the broom comes through, pulling that wave, it comes through. It also, not only is it helping seal the cracks, but it's helping to smooth that over to give you a nice full surface. Is it a cure-all? No, but is it insurance to make sure that you get good coverage for your emulsion across the road? Yes, you can see how smooth that is. It would be that's going to be a really nice surface to drop your aggregate in with your chip spreader when it comes through. All right, now here's what we're trying to do. I believe these pictures were taken in Oklahoma, but basically what was done is they went out and they found a crack, they marked it, located it, and then after the chip seal was done, they cored it to see what kind of penetration that they were getting from this. And this picture doesn't, on my right, I guess you're right, it doesn't show it very well, but you got about 1 inch of penetration, but when you open that crack up, you can kind of see what we got there. And maybe if you don't fill that crack all the way up, maybe it's not such a bad thing, because at least you're getting a lot of emulsion down in that crack to prevent as much water as possible from getting in there. It's better than not having anything at all. If we think about the way that a pavement deteriorates, the best that it's ever going to be is the day that it goes down, right? And then we've all seen the pavement deterioration curves. As it comes down, as the pavement oxidizes, it gets harder, and when it gets harder, it gets more brittle and more cracking appears. Generally, we would say that a good pavement has 15 to 20 years worth of life. Now, we're at a pavement preservation conference, and I know that we've talked about pavement deterioration curves. Basically, one of the main benefits that you can get out of a scrub seal is that you have an area, you have an opportunity, a window of opportunity to actually use it farther down the curve than what you would really be able to use any other treatment. The good thing about a scrub is that it can actually treat some defects in the road that maybe would only be addressed with mill and overlay. We've seen some of these in these other slides where they were talking about their pricing, and we know that when treatments are up above where structural damage appears, that they can be used as just routine maintenance, which would be your crack sealing, your fog seals, your scrub seals. But after that, it's going to be structural, which is going to be more expensive to repair. Like I mentioned, that a chip seal, maybe that area of opportunity, that window of opportunity to use that treatment is going to be up on the curve, where we can use a scrub seal later in that curve into the section of the curve where it is steepened and deteriorating faster. And this is a way to use a treatment a little further down the curve and save what you can. And that brings me to one of the best practices that we can do, one of the first ones, and we've said it before, and it's just picking the right location. These windows of opportunity, these candidates that we have often will be an optimum candidate, an average candidate, or maybe a stopgap measure. And understanding what your expectation is for the road that you pick is vital for your pavement management plan. If we wanted to pick an optimum pavement, something that was going to be up maybe at the top of that window of opportunity, we would be looking at a road that has a PACER rating or maybe a PCI rating of somewhere of a 70 to a 70 on the PCI scale, okay? Now what that basically means is that if we use it in that window of opportunity, we should expect about 8 years worth of life. Now these numbers that I'm presenting here came from roadresource.org. You can get on their website, pull those up, and read through that in their section. But what we're looking at for an optimum candidate is a road basically of what you see in this picture here. It's going to have cracking. Generally, it's going to have, like I mentioned, a lot of cracking that would be too much to seal with a wand, but it's not going to have any base failures, not going to have any sections that are going to pump or move, anything like that. It's going to have a really good structure, but it might have some pavement wear, might have some rattling, it will have some oxidation, and maybe just the appearance of first part of block cracking and things like that. Now, when we want to look at an average candidate, this is going to be a PACER rating of somewhere around a 4 or a 5. Now, with PACER, generally any road that has any kind of structural defect in it gets a 4. The highest it can get is a 4. Rutting, things like that. Now, rutting is something that may start to appear in this window of opportunity, and it's not encouraged to use a scrub seal on a rutted road. You can expect bleeding or flushing at a minimum in that section, but there are times people will choose to do that, especially if it's an interlayer or something like that, and they're going to cover it back up. But generally, it's not encouraged to use a scrub seal in a road that's been rutted. And here you can expect, if in this category, you can expect your life expectancy to be about 5 years for this treatment. And then this is kind of the picture of what we're looking at. It's going to be more than 50% block cracking. You're going to have a lot of longitudinal and crackings, traverse cracking, a lot of traffic wear, raveling may be there, more oxidation. But that's what you're looking at. But if you do start to get some structural damage in this, then it's important that we patch those or level those, give those patches time to cure out before you come back in and use this treatment. If you don't, a lot of times what will happen is the emulsion, instead of staying up on top of the patch to act like a glue to lock your rock down, will actually be absorbed into the patch, and then the rock won't stick to the patches. So it's important to give those time to cure, or either go pre-treat those patches with maybe a fog seal or something like that. Now, the last thing I'd like to point out here on the windows of opportunity is the stopgap measure. This is where you really shouldn't do this with a whole lot of expectation. A chip seal is not used to add any kind of structure to the road. It's not going to band-aid the road back together. In this situation, maybe you're just hoping to maintain some ride quality until you can get a better treatment, or maybe come in and do a rebuild or something like that. And about the best that you can hope for is 1 to 3 years. It's not a chip seal or a scrub seal that you're going to be using here is not going to cover up these bumps that you see. It's not going to repair this patching. It's still going to be noticeable, but maybe it holds us together for just a little bit longer to give you time to come in and do a better service later on down the road. Talk a little bit about the value that you would get for picking the right candidate. Now, if we use the years of life, the 8 and the 5 and the 1 to 3, and we use an average national cost of $35,000 per centerline mile, if you pick an optimum candidate that gets 8 years of life, you're basically going to put about $4,400 a year into your road to maintain that road. For an average road, you can see that it'd be about $7,000 per year. So what that basically means is that picking an optimum candidate, you're going to get 1.5 times more value bang for your buck versus picking over an average road, and up to 8 times more value picking a road that's a stopgap measure. So that really kind of points out to you why it's important to pick the right candidate at the right time. And once you've kind of picked your candidate and you know your expectations, then the next thing that we need to another best practice that we need to do is we should talk about specifications. Specifications can be the key to whether we have a good project or not. They're going to call out things like materials and your equipment and your application rates, your quality control, your measurement and payment. All of those things are going to be broken down in there. When it comes to materials, it's very important to make sure that we talk about the type of rock, that it meets the specification, that it's clean. A lot of times in one area of one of the states that I deal with, one of the specs that floats around really didn't limit any of the dust. So a lot of times we would have a lot of rock that would come off. So we need to clean those up and make sure that we have good specs and that we use good materials. And then another thing that I think is very important, and this is not used in all of my states either, but I think a mix design is very important to be a part of your specification. And the reason is that one, we just want to make sure that those materials are compatible and that they get along and that they will work. The other thing is it gives the contractor a starting point. What I mean by that as a starting point is that just because you do a chip seal design, it doesn't mean that is the holy grail of what we need to do out there on the project. You need to take into existing conditions, or maybe conditions change. Maybe you get on a road while we're doing a scrub seal and the volume of cracking increases while you're out there on that road. Well, we might need to increase the shot rate for your emulsion at that time. Maybe the road decreases, or you actually change the surface. It goes from a chip seal to a hot mix road or something. That might require the difference of changing your rates. Maybe the conditions of your stockpile, the aggregate or something like that, has a lot of elongated or flat chips and things like that in it. Well, maybe we need to back our rates down a little bit to keep things from flushing. So it's important to have somebody out there that's kind of watching that, but a mixed design is one that's, like I said, it's going to tell you that your components play nicely with each other, and two, it gives you a start point. The last thing I'd like to kind of point out for the measurement and payment is Oregon did a chip seal study, and they've got some published information out there, and I thought it was really interesting that they were seeing that when they the way they structured their measurement and payment could actually encourage contractors to do best practices. And one of those that they found out was if they would just pay for the emulsion by the gallon and pay for the rock by the square yard, it encouraged contractors not to cheat on the gallons of emulsion that went down, and it also encouraged the contractor to not over apply on the rock. I've been on a job before where the job was structured as ton and gallon, so the contractor had put profit into the tons that he was going to use, and if he didn't use all of the rock on his in his chip spreader when he was spreading it out, he would load his dump truck up and actually tailgate spread that rock on top of the road after it was over with to make sure that he used all the rock. Well, what that ended up doing was any rock that was glued down to the surface actually would get knocked out by that loose rock, but it was important to him to use it. So it's important to think about each paying by the square yard, paying by the ton and gallon. They all have their pluses and benefits, but I think it's important to think about how we structure those contracts sometime to encourage best practices by the contractor. Another thing a good specification is going to do is that it's going to clearly define the level of communication between the agency, the design engineer, the contractor, and most importantly, really for the inspector, because when we get to this point of the job where the inspector's involved, he's probably the most important person at this point to be successful. Besides picking the right location, this guy probably comes next. And the problem with the inspectors a lot of times is that they are the youngest team member with the least amount of experience. When you get contractors who have been in the business for 40 years, who maybe don't have the best motivations, and you get a guy that's 25 years old, fresh out of college, a lot of times that contractor can maybe bully that inspector a little bit. So they need to make sure that the inspectors have the right knowledge and the right job site experience to help understand what the contractor may be doing right, what he may be doing wrong, and then actually help, hey, let's go out there and if there are problems going on, be a part of the solution. And that brings me to the third thing, is that education for all parties is really, really important. One things that I like to do in my areas when jobs are coming up, I've been asked to come out and maybe kind of lead a discussion between the inspectors and the contractors at maybe a pre-construction conference. And it can really if you do those, it can really set off the project headed in the right direction, set it up for success. There was a project that I was on last year where I think education was really the key to this, because the contractor had never done a scrub seal before. He had a distributor. He had done chip seals 10 years back, but he had not ever done a scrub. And he had no experience whatsoever. And when I asked him, I said, "Do you even know why we're doing this?" He didn't even know what they were trying to accomplish. But he bid on it, he won it, and now he had to figure out how to do it. The inspector on the job also had never been on a scrub seal. He didn't really know what it was. So we took about 2 hours, and I brought a computer out. I showed a bunch of pictures. I talked through setup. I talked about application rates. And even I was a little concerned about this spec, because the spec was, the application rates were too full. They had too much emulsion and what I thought was probably going to be too much rock. But after explaining to everybody out there that was likely to be a problem, if you just stuck really hard with that spec, that you were likely to have a big mess, it kind of opened their eyes when they saw the pictures, and we were able to work as a team and pull that down and adjust those shot rates to where the agency was very happy when that job was over with. Now here's an example of what can go wrong when the person is not educated or there's not an inspector. I don't know where the inspector was on this picture when this picture was taken, because this scrub seal was done when it was raining. And I can guarantee you that the spec said somewhere in there that we're not going to work in the rain. But as you can see, all the rock is not sticking to this road. It's going to the side of the road. So just paying attention to your spec, educating your engineer, or educating your contractor, or actually holding him accountable and not letting him work in the rain, this was avoidable. Here's another picture. I like to show this picture, is that I'm not really sure what happened on this scrub seal and why we had bleeding. It might have been the aggregate, it's something, but it was likely that there was some rutting here beforehand. And some of those conversations that I like to have at that pre-construction conference is to point out to the inspectors sometimes that if the road is rutted, it's not the contractor's fault at this point that this thing bleeds. It was just a bad site selection. So it's not fair to hold the contractor accountable to try to repair this if you picked that road in the first place. So it's just best to come to an understanding of saying, hey, you're likely going to have some bleeding out here, okay? Here's a road that's actually not too far from my house. Now, the really painful part of this road is that the district engineer for that area traveled this road home every day. And after this road was done, he called me and about 6 o'clock on his way home and said, what's going on with my road? It didn't leave a good taste in his mouth. He was not encouraged to do other roads for a while until he felt like this contractor had a better grasp of things. But what we see here is that line that you see there that's labeled A is the contractor didn't take the time to maintain his broom and keep his broom set up in a right condition. And those broom heads actually had separated. And that's a flushed spot that lasted for several hundred feet. Now, it's just an eyesore. In the summertime, I would expect maybe a little bit of asphalt to stick to a tire or get on a vehicle or something from that area. But it would have been avoidable had the contractor just taken the time to maintain his equipment. That area of B is an area where we have a bunch of corrugations that are there. I suspect what happened, that's a picture of his broom. His broom was completely crusted over in solid pieces of asphalt. He had actually changed out one broom head in that picture. That was all he would agree to, or well, you see a few maybe in the bottom down there, but he wouldn't change out any more. His comment to us was that as we get to pulling down the road, this rejuvenator in there is going to soften that asphalt up and everything will start working. What I think probably happened with those corrugations is that broom was acting like a squeegee and he was pulling it in a way that it got to bouncing a little bit and the asphalt came out underneath it in waves, got the rock in it, and it became a corrugation. And now it's going to be there until they mill that road. Again, it was avoidable had he maintained this. Now, when I took this picture of this, this was not a state job, this was a county job. And when I took the picture, we were trying to encourage the inspector that was out there that day to encourage the contractor to replace all of his broom heads so that we would get a good product. And the inspector told me on this one, he said, man, I'm leaving, I'm retiring on Friday and I'm going to be fishing on Monday. This is not my problem. I warned him that this was not going to be a good look. This was not going to turn out well. And sure enough, the agency that after this road was done, the agency that was over it was not pleased with the road. And that area engineer for that area said that he probably would not use a scrub seal again due to what we see. Now, what that means is that he just took a very valuable treatment out of his toolbox, one that would maybe cost him about $4 a square yard, and now he's going to replace it with something that's likely going to cost him about $10 a square yard. It's unfortunate, but just bad construction work and people that were not educated and lazy and whatever has really cost that county another treatment for the time being. This is just an example of what we don't want to do. We don't want our brooms to be pushed down so heavy that they act like squeegees. We want to be able to have a broom that's set up high and nice that will actually let the emulsion flow through it, but will also act as a way to scrub that emulsion down into the crack. Here's the last picture I'll tell you about. Remember the first thing I told you about the 2-hour presentation that we did out on the job site and the job went well? Well, the reason why I think education is really important is because same contractor, about 3 weeks later, completely different crew and completely different inspector. And one of the things that I talk about in all of our best practices is this piece of equipment right here is your chip spreader, is that it's always important to keep your chip spreader as close to the brooms as possible, okay? We want to be able to drop that chip while that emulsion is still very fresh and give it time to cure around the trip and not cure before the chip gets in it. It's really important, especially when temperatures are out there like this day where we're close to 100 degrees. But as you can see, the contractor, distributor driver didn't get that point, and he decided to take off and go paint the road black, and the chip spreader decided to take 30 minutes and fill up. That's all I got. Any questions?
What are the typical application rates for the emulsion and stone that you see?
Well, I would be amiss if I don't say it depends. We have, I'll tell you a quick story of what we saw in Mississippi. We got 5 aggregate suppliers to give us aggregate, and we ran all of those aggregates to just check them against the spec and to see where they fell. And the way the specs are set up is that they have a gradation range that they're supposed to meet. Well, all 5 of those rocks passed gradation, but they varied so much that when we ran the chip design, the mix design indicated as much as 1/10 of a gallon difference in those shot rates, and they were all within spec. And that's a lot when the average rate up there is 0.3 gallons for a rock that is about the size of your little fingernail, and a 0.35 to 3.6 gallons for a rock that's about the size of your thumbnail. So it really depends. That's why I say it's important to do a mix design to let's get as close to that a good rate that we can.
Stan, great presentation. I had a couple questions about the broom itself, and maybe you can answer or some other people in the audience, but in one of the videos I saw the wheels of the broom sled itself rolling along. In my head I would assume that those would need to be up, but is that one of those cases of it depends, just so that you don't get that squeegee effect?
Yeah, what happens sometimes are that sometimes you have contractors that decide to build their own brooms. Other contractors will buy brooms, and so they're made with different materials. They'll have different weights. Broom heads do wear out, so they'll start to get heavy and start acting like squeegees. So this contractor solution was to just let the pressure of the wheels hold that broom up at the proper elevation. Other brooms have jacks that you screw down that act as sleds. They have wheels that are spring loaded, things like that. It's a design function of the broom.
That kind of leads me to my next question is, you talk about a good specification. Specifying what you want out of that broom seems like an important part too. And I'm curious if there's like a national or an AASHTO spec on a good broom sled, or if there are plans for something of that sort.
In all of the specs in my states that I'm familiar with, they give out the concept of the broom, and they show pictures and diagrams of a minimum expectation of what they expect to see. I do think that there is an AASHTO spec that is in development for scrub. I may get corrected on that, but I think there is one coming in the future.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.